Hello everyone, welcome back to Some My Tutorials, class BCA third semester, NIP syllabus. Concept is Database Management System. This is the session number 4. Chapter 1, Database Architecture. So first let me know about three-level architecture. So this diagram shows that the DBMS architecture. This describes how the data in the database is viewed by the users. In this architecture, the overall database description it can be defined at three levels. That is called internal level, conceptual level, and external level. External level we can also call it as the view level. So that is named as three-level DBMS architecture. So this architecture is proposed by ANSI or the SPARC. That means American National Standard Institute or Standards Planning and Requirements Committee. Hence the name ANSI, and SPARC is known as ANSI SPARC architecture. This diagram which shows that mapping between external, conceptual and internal level of the data based in the DBMS concept. In this architecture, it has the three different level. So what are the functionalities of internal level, conceptual level and view level? So first let me know about internal level. Internal level is the lowest level of data abstraction, deals with the physical representation of a data in the databases, so that we can call it as the physical level. So once again I'll repeat. So this is the lowest level of data abstraction that deals with the physical representation of a data in the database, so that we can call it as the physical level. This physical level, it describes how the data is physically stored and organized on the storage medium. At these levels, various aspects are considered to achieve the optimal runtime performance and storage space utilization. So this is a functionality of internal level. Second one, conceptual level. This level of abstraction deals with the logical structure of entire database. Thus, it is also known as logical level. This conceptual level describes what data is stored in databases and relationship and relationship among those data and complete view of the user requirements without any concern of the physical implementation. So this hides the complexity of the physical storage structure, so that we can call it as the logical level. We can also call it as the conceptual level. The third one is the external level. External level is the highest level of data abstraction that deals with the user view of the database. Thus, it is also called as the view level. In general, most of the users and application program don't require the entire data stored in these databases. The external level describes a part of the databases for a particular group of users. It permits users to access the data in a way that is customized according to their user needs, so that the same data can be seen by the different users in the different ways at the same time. So this is the functionality of the external level. So that the three-level architecture, it can be categorized into these three types: internal, conceptual, and external level. The next slide, we move on to the here data independence. Data independence means what? Data independence is ability of a database to modify the schema definition at the one level without affecting the schema definition at the next higher level. So that, on the other hand, ability to change the conceptual schema without affecting the external schema or application programs. There are two different types of data independence. The first is called physical data independence. Second is called the logical data independence. Physical data independence is that the ability of a database to modify a schema definition at the one level, which means that schema definition at the physical level without affecting the schema definition in the higher level. That is called the conceptual level. So that is called physical data independence. So same as like that, logical data independence is the ability of a database to modify a schema definition at the conceptual level without affecting the schema definition in the higher level, that is called the view level or external level. The next slide here, database languages. In the DBMS concept, the programming languages which are used to create, operate the database, so that are called as the database language. So some most commonly used database language is SQL, that is called Structured Query Language. The DBMS has the appropriate language and interfaces express database queries and updates also. Database languages can be used to read, store, and update data in the databases. So here are the most commonly used database languages in these five categories. So based on the types of the users, so first is called data definition language, that is called DDL, data manipulation language, that is called DML, that is data control language, it is called DCL, then data query language, that is called DQL, then transaction control language, that is called TCL. The first one is data definition language. So what is a data definition language? So data definition language is used to define the database structure or the pattern. So it is used to create the schema or a table or an index or any constraints, so or etc. in the databases. So that the DDL statements you can create the skeleton of the databases. So that these are all the languages is used to store the information of metadata. What is a metadata? The data about the data, it is called the metadata. For example, the number of tables and schema. So that their names, their index, their column in the each column and their constraints. So these are all data of the data or the table or the schema. So here are the most some tasks that come under DDL. It is data definition language commands which are create, alter, drop, truncate, rename, and also comment. So create. So what is the function of the create command? It is used to create objects in the database, or it is used to create the tables in the databases. That is a functionality of create command. Second one, alter. It is used to alter the structure of the database. So create, it is used for creating the database. So alter, it is used to alter the structure of database. Then drop. Drop command is used to delete the table from the database. Drop command is used for delete the table from the database. Then truncate. It is used to remove all records from the table. So truncate means the remove or the deleting. Then rename. Rename is used to rename an the table or a database name. Then comment. Comment command is used to comment on the data dictionary. So that these are all some of the different DDL commands in the DBMS concept. The next one, data manipulation language. Data manipulation languages are used for accessing and manipulating data in the databases. It handles the user request. So here are some of the examples. Select command, insert command, update command, delete command, merge command, call command, explain plan command, log table command. Select command is used to retrieve data from a databases. Then insert command is used to insert data into the existing table. Then update command is used to update existing data within a table. Then delete. Delete command is used to delete all records from the table. Then merge. Merge, it performs upsert option. That means insert or updating operations. Then call. Call command is used to call a structured query language or a subprogram. Then explain plan. This command, it has the parameter of the explaining data. The last one, log table, it controls the concurrency, that is simultaneously. These are all the sum of the different DML commands in databases. Then third one, data control language. Data control languages is used to retrieve the stored or the saved data. This DCL command's execution is the transaction and also has a rollback parameters. Here are the sum of the DCL commands, grant and also the revoke. Grant command is used to give user access privileges to the databases. Same as like that revoke. So that this command used for to take back a permissions from the user. The grant is used to give the user access privileges to the user. But the revoke command take back the permissions from the user. So these two are the commands that are called DCL. Then data query language. Data query language. This is a formatting language which is used to get or retrieve any data from the databases in the form of a query. So this format creates the different queries and also helps the database to understand the remaining part of the query except the commands, so that all the queries in the databases that are belonging this category, it is called DQL. Example, that is select. Select star from any table. This is one of the example for the data query language. Then last one, transaction control language. Transaction control language is used to run the changes made by DML commands. So TCL can be grouped into a logical transaction. Here are the two examples. One is the commit. One more, it is called rollback. Commit command is used to save all the transactions on the database. Rollback command is used for restore the database to original since the last commit. So these are all the some of the different databases languages in DBMS. Next slide, we move on. Here, classification of the DBMS. The most commonly used databases which are hierarchical databases, network databases, object-oriented databases, relational databases, and no SQL, means non-SQL databases. So that here, first category, hierarchical databases. So first of all, database means what? Database, it is a collection of the logically related data items. So that can be easily accessed, managed, and also updated. This is a definition of a database. Here, a hierarchical database. Hierarchical in the sense of it's a tree-like structure. In this the hierarchical database, this database follows the progression of a data being categorized in the rank levels. That is called level 1 or level 2 or level 3 or level 4. That is where the data is categorized based on the common point of a linkages. As a result, two entities of a data will be lower in the levels and that would assume in the higher rank. So that this diagram which shows that the levels, that is university, it is a level 0, department and administrator, it is a level 1, then student, faculty and resources, this is a level 2. So that hierarchical in the sense of it is a tree-like structure. The topest node, it is called the level 0 category, and the next level it is called the level 1 category, and the next level it is called the level 2 category. So in this example, the university, it is a level 0, The department administration, it is a level 1, and students, faculty, and resources, it is a level 2. So note that here department administrators are entirely unlike each other and it fall under the domain that is called university. So here the department and administration, there are the two entities. These two are under the category that is called the university. Here are the elements that form this hierarchical system. Another perspective advises visualizing the data being organized in the parent and also the child relationship, which upon the addition of the multiple data elements resembles a tree-like structure. The child records are linked to the parent record using a field, and so that the parent record is allowed the multiple child record. So however, the vice versa is not possible because the child cannot have the next child nodes. The parent, it can have the many number of the child nodes. So this is a databases, we can call it as the hierarchical data structure. It has the parent and child relationship. We can also call it as the tree-like structure. Then second category, that is called a network databases. In the network databases, here is the hierarchical database, but with the major twist is that here the child records are given the freedom to associate it with the multiple parent record. So here this is a child node, the department and administration. These are all the child nodes. So but it is linked with the other nodes, that is like the club. So that the one child node, it can give the freedom to associate it with the multiple parent node. So as a result that the network of a databases file that are linked with the multiple threads. So that is observed in this the diagram. So this diagram which shows that how the student, faculty, and resources elements each have two parents record. So which are the department and also the club. So here the student, faculty, and resources. So these are all the child nodes. So these child nodes that are all having the two parent records like the departments and also club. So that this diagram which shows that the network databases, in simply we can call it as the one child node, it can give the freedom to associate it with the many number of the parent node. This type of a database we can call it as network database. The third one here, object oriented database. Object oriented databases, this is a paradigm could be able to relate to this model of a database is very easy. The information is stored in these databases are capable of being represented as an object which responds as an instances of the database model. So therefore, an object can be referenced and called without any difficulty. As a result, the workload of the databases is substantially reduced. So here is the diagrammatic representation of the object-oriented databases. So in this chart, we have different objects linked to one another using the methods. So one can get the address of the person that is represented by the person object using the lives at method. Furthermore, these objects have an attributes which are in fact the data elements that need to be defined in the database. So for example is that, so here is the person. The person, it has the number of different attributes like name, phone number, email. And this is go to the student record. The student is another object. It has the attributes like roll number, average, and is it eligible to an enroll. Or one more object is a professor. It has a two attributes like salary and qualification. So here is that all the different attributes which are or different objects linked to one to another using the methods so that one can get the address of the person and others that get the another information. So this type of the database, we can call it as object oriented database. So object oriented database, it is everything, it is an object, all the data and all the functions which are communicated through the objects only. So then the relational databases. The relational databases here, they considered the most mature of all the databases. These databases lead in the production line along with their management system. So in this type of a database, every piece of information has the relationship with every other piece of an information. So this is an account of every data value in the database having the unique identity in the form of a record. Note that all the data is tabulated in this model. Therefore, every row of a data in the database is linked with the another row using the primary key. So in the simple definition is that relational databases, everything, every data that is in the form of the table. The table, it consisting of the rows and columns. The rows is represented as the data. The columns are represented as the attributes. So that is, note that all the data is tabulated in this model. Therefore, every row of a data in the database is linked with the another row using the primary key. Similarly, every table is linked with another table using the foreign key. So that this diagram which shows that the concept of the keys using the link between the two tables. So due to this introduction of a databases to organize the data, it has become the exceeding the popular. In the consequences, they are widely integrated into web app interfaces to serve as ideal repositories for the user data. So here is the fourth category, relational databases. Here is that the one table and another table that are all linked with the foreign keys. So that these are all some of the different types of databases in the DBMS. The last category is the NoSQL. That means NoSQL, which means that is a non-SQL, which means non-relational is a databases that provides the mechanism for storing and retrieval of a data in the databases. This data is modeled in means of other than the tabular relations used in relational databases. So that is this category, we can call it as non-SQL databases. Thank you. This is the end of this session. If you like my videos, please do subscribe to my channel and click on the bell icon for the notification of the new videos. Thank you so much.